Another good question comes from the house of mechanics. One, it's important for JEE Advanced. In this question, we are given a small block of mass m which is thrown with a velocity u to the wedge in a manner as shown in the figure. Mass of the wedge is m, capital M, and we are required to find the speed at the topmost point, which is the point A of the wedge. Here we are required to find the speed of this block and also the maximum height reached by the block above the ground, and the height of the wedge is h. Starting from the conservation of momentum, conserving linear momentum, conserving linear momentum. Initial momentum is mu along the horizontal direction. Mu equals to, since this has reached up to some height on the wedge, so it imparts some velocity to the wedge, say v1, and in turn it gets a velocity v2 which is vertical, since this part of the wedge is vertical, and by the constraint relation, this velocity along the horizontal direction, the velocity of the wedge block is also v1. So we are conserving the linear momentum along the horizontal direction, and we'll get m plus m v1 equation 1. Now from the work energy theorem, we get total work done equals to the change in kinetic energy. Total work done is done by the gravitational forces only, so it is minus mgh equals to half m v1 square plus half m v1 square plus v2 square minus half m u square minus 0. It is for the wedge, it is for the block. Minus mgh equals to half m plus m v1 square plus half m v2 square minus half m u square again minus mgh equals to half m plus m, this is mu over m plus m raised to the power 2 plus half m v2 square minus half m u square minus mgh half m square u square over m plus m plus half m v2 square minus half m u square. We'll get half m v2 square equals to half m u square minus mgh minus half m u square over m plus m. We'll get half m v2 square half mu square I'll take as common, and we'll get 1 minus m over m plus m minus mgh. Then we can do one thing, that half mv2 square equals to half. It's turning out to be a bit boring, but we need to solve this. So v2 square is equals to mm upon m plus m u square minus 2gh. This is reduced mass mu, so v2 square is equals to mu u square minus 2gh is the answer of v2, is the solution value of v2. Now we are required to find the speed. Speed of the block is given by root over v1 square plus v2 square. Speed at point A, and written as v1, it's mu over m plus m square plus v2 square mm over m plus m u square minus 2vh. After solving, we'll get take u square as common, and m is also common. This is m over m plus m to the power 2 plus 1 over m plus m minus 2gh. This goes to power 1 by 2, and it's square brackets. This will be capital M square plus this will be m plus m square plus mm plus m square over m plus m to the power 2 times u square minus 2gh. This is the value of the speed at point A. Let's check this once. This is a value of v2 square. v2 square we have substituted here, and v1 square is this value. So the squaring we get, taken out the common as this. Here remains only this. I think it's fine. Now we are required to find the maximum height above the point. We are required to find the maximum height above the ground, since it has already reached a height h before leaving the wedge. So after detaching, it only gets the velocity in the upward direction, which is V2, and V1 just vanishes out. The velocity in the horizontal direction just vanishes out. You can easily check it, and it's so maximum height can be written by V2 square over 2g, and we can substitute the value of the V2 calculated above here and get the final answer. So this question has been solved.